My name is Jeremy Jordan, and I'm a machine learning engineer at Duo Security. And as been mentioned, also one of the organizers of the conference. So thank you all, everyone, for coming out. Thank you all to the speakers that have given some wonderful talks today. It's really, really exciting to see everything coming together. So today I will be talking about machine learning and rules engines and how they can work together. So let's start by walking through the life cycle of a typical machine learning project. Let's pretend that we work at an email company and a product manager comes to us and says, hey, users are complaining about spam. Can you filter out those messages? And so we say, yeah, sure thing. And we get to it. So where do we start? The kind of like the standard advice is to start with a rule-based approach and deploy that into your product. Like this is literally rule number one on Google's great guide to machine learning. And there's a good reason for that. And that's that, machine learning requires ideally labeled data. And we don't necessarily have the luxury of having that at this stage. So instead, we spend some time to get familiar with the problem and build up some domain expertise that we can encode into a heuristic. So we can start off by writing kind of like, just a simple rule that looks for spammy keywords in the email body and then deploy that into our product. And now that we've rolled out a spam folder into our product and are using that heuristic that we just wrote to decide which content should be placed in that folder, we can start to observe user behavior. So we can see when users move emails into the spam folder. And we can also see when users move emails out of the spam folder back into the inbox. And just like that, now we have a labeled data set to work with. So now we're cooking. We have labeled data, a better understanding of the problem we're trying to solve, and we can go ahead and replace that simple heuristic with a smarter machine learning model to identify spam. So we'll take that data that we observed from user interactions in our product, instantiate a model, fit it to our data. Great. Now we have a model that we can use to replace that heuristic that we deployed in the first iteration to now improve our product. However, I've learned that it doesn't always work this way. And specifically, I've been working in the field of cybersecurity for the past 5 or so years. And working as a machine learning engineer, just for some context in cybersecurity, I've mainly been focused on threat detection tasks. So this is things like detecting phishing URLs or malware attachments in emails, and trying to identify when bad actors might be trying to log into your accounts. And threat detection exists in an adversarial environment. As we get better about detecting and blocking malicious content, threat actors find new vulnerabilities to exploit. This means that the threat landscape is constantly changing, and we need to be able to keep up with those evolving threats. And spoiler alert, this is typically done using both rules and machine learning, since they each have their own unique advantages, which I want to touch on. So let's talk a little bit about rules. Rules are honestly pretty great. They allow us to directly encode our domain knowledge about threats and the threat landscape in the rules that we write. We can also easily update those rules to fix false positives quickly when like a customer complains about something getting blocked. Hopefully you haven't experienced this personally, but blocking benign content can be very disruptive, and we definitely want to be able to make sure that we can remediate those false positives quickly after we learn about them. Rules also allow us to react quickly to new threats. We may learn about a new threat through a research briefing and want to provide protection against that threat before we actually see that threat in our product data. And if you're curious like how that might work, a lot of research briefings will include useful information they call like indicators of compromise. Think hashes of known bad files, for example, that we could use to quickly write a rule. So, just to give you an example, here's a recent threat research report on some new malware variant, along with some of the file hashes that we could use to detect known samples. And then finally, rules have interpretable logic, which makes it easier to understand and fine-tune the rule. And we can look at a given rule and kind of reason about why it classified a piece of content a certain way. But machine learning is also pretty great. It's much better at generalizing to unseen data. And this is useful in a variety of settings. I've built threat hunting tools that leverage machine learning and semantic search that let a threat researcher say something like, here's some malicious content that I'm interested in. Can you show me similar examples? Or maybe, can you show me examples that have this particular aspect in common? And this can be very useful for tracking the evolution of malware, for example, over time, as those files evolve and are changed to try to evade detections. These models can also be useful for, kind of just like being able to learn more nuanced, complex decision boundaries than rules might be able to, and allow us to discover new threats when we're using them for, classifying malicious content. And part of that's because, as I mentioned, we're often very sensitive to false positives. So we have to write, when we're crafting rules, we have to make sure that they're very high precision. So those rules can usually end up carving out like very narrow areas in feature space. So sometimes kind of my mental model is like a model can help fill in some of those gaps. And another nice thing about machine learning is we can automate the process of figuring out the proper detection logic. So this is simplifying things a bit, but as long as you have a labeled data set, you can kind of let computers figure out the rest as far as classifying that malicious content goes. And then that aspect becomes very powerful as we continue to collect data from product usage, as it enables us to easily retrain our models and improve them over time as we collect more data. And that's one thing that you can't really do with rules. You can't necessarily take recent product data and call fit on a rule to make it better. And then finally, I'd argue that the maintenance costs scale better than rules. The maintenance cost for machine learning scales better than rules. I think rules can be great for simple logic and capturing low-hanging fruit, but you can reach a certain complexity where it starts making a lot of sense to leverage machine learning. And so from another perspective, just to kind of help visualize this, if we were to look at a precision recall curve, one of the ways I think about this is kind of rules helps us capture some of the low-hanging fruit and capture threats that are easy to express in a rule. But adding in machine learning to the mix, we're able to kind of push out that Pareto frontier and detect more malicious content. And again, when we're making blocking decisions based on threats, we have to make sure that we have extremely high precision. So in practice, adding machine learning models to complement the rules really helps us kind of push out our recall and stop more threats from causing users harm. But ultimately, these two systems are strongest when they're used together. And I think that that's the really important point that I want to emphasize here, is that each of these two systems have different perspectives on the data, and combining those perspectives gives us a unique vantage point. We're able to look at subsets of the data where the model and rules agree, as well as highlighting subsets of the data where the two systems disagree. And those disagreements or discrepancies are a really useful tool for triaging human review of data, where we can investigate and go in and attach a ground truth label to that example. So, for example, we can look at a mocked up discrepancy feed here, which compares the outputs of a rules engine and a model prediction. And we're able to surface data where the two systems are disagreeing. Humans can then come in and review this discrepancy feed and attach an ultimate ground truth label to resolve the disagreements and improve the individual detection systems. So, for example, we have a row here where the rule classified the data as malicious, but the model said it was benign. And after human review, we concluded that it was in fact benign. In this case, we now know that we need to go fix that rule to reduce its false positive rate. And then in this case, we have a rule also classifying a piece of content as malicious, where the model says it's benign. And after human review, we concluded that it is in fact a malicious piece of content. And so we'd want to take that example and maybe some other similar examples, make sure they're all labeled, and then include that in some of our training sets so we can retrain that model and improve that model's performance. Ultimately, to build kind of an effective threat detection system, we need to have a layered defense. And this includes some manual effort, kind of exploring the data and hunting for threats, developing rules to encode our domain knowledge of the threats that exist, and training models to help scale our detection of malicious content. We can leverage discrepancy feeds to help improve our rules and machine learning models. And ideally, we can also capture user data and feedback and incorporate that data in our model training as well. So hopefully you can start to gain an appreciation for the values of both rules and machine learning in a threat detection system. And one topic that I've been thinking about a lot lately is how we can make this all work well together. So I'll talk through a couple things that I've been thinking about here. The first is being able to package rules and machine learning models such that they look similar at inference time. And this allows us to easily start with a rule and deploy that out for a given threat, but just as easily introduce machine learning models kind of in parallel as we've collected more labeled data into our detection stack. There's a really cool library by one of our NormComp speakers today, Vincent, called Human Learn, which basically lets you craft rules and wrap that into a scikit-learn interface. So if you're at all interested, I highly recommend you check it out. Vincent has some great examples and documentation to get started on that. And I think it's a very interesting kind of like library and approach to making inference look the same. I also think it's incredibly valuable to be able to track and evaluate these models and heuristics using common infrastructure. So after writing a rule, you should be able to run it through an evaluation set and capture important metrics for that model at the time that you authored that rule. And then after training a machine learning model, we can run it through that same evaluation set, capture those same important metrics that we care about. And all of our experimentation data and context can easily be stored and discovered in a single tool. And then this can also carry over into something like a model registry, or I guess in this case, a model plus rules registry, where we can link artifacts back to all the data that we have in our experiment tracking system, as well as have a kind of centralized control plane for rolling out new artifact versions to production. And this can be really useful in quickly answering questions like, what models are deployed right now? Did we make updates to that one heuristic? And this detection rule seems to be firing a lot. How often did it fire, like in our evaluation set? And then finally, when we have multiple systems making judgments about a certain piece of content, we need to be able to combine those outputs into a single decision. So this concept of a policy layer, which is kind of responsible for defining how those outputs should be combined, becomes important. And in some cases, the policy might be super simple, like just a logical or statement. So if any subsystem classifies a piece of content as malicious, then we'll go ahead and block it. Or in other cases, you might have some more complex logic here, such as scenarios where you may not trust the machine learning model's output. Like maybe that machine learning model has low certainty on a specific piece of data, and you want to be able to fall back on the rule system's output. Or let's say the machine learning model has a false positive that a customer reported, and you want to be able to very quickly remediate that. You might want to be able to override the model's prediction for that specific scenario in the policy layer. And ultimately, I think as we take a step back to kind of look at the big picture, machine learning exists as a part of an overall threat detection system. So if you were just listening in to Peter's talk, I thought it was a really great point about kind of like, machine learning is the carbon fiber material. And you wouldn't build an entire bridge out of carbon fiber, but it's a very useful material that you can use. So in my experience, I haven't actually seen the scenario where we replace some initial rule-based logic with the machine learning model. Instead, the two systems, at least for threat detection scenarios, the two systems kind of work together in a symbiotic fashion. All right, that's all I've got for today. I hope you found it interesting to kind of learn a little bit more about the world of threat detection and how rules and machine learning models can work together to improve the overall threat detection system.